Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. Today we are going to discuss question number 7. Yesterday we left question number 7 and 8 of this chapter number 6, and we will conclude this chapter after doing these two questions. So let us start directly. Question number 7, which is on page number 96. A rubber ball of mass 0.12 kilogram. So we are writing M is equal to 0.12 kilogram. Uh, is held at a height of 2.5 meter. So I am writing height as 2.5 meter, and that is held 2.5 meter above the ground and then released. Number one part is saying that calculate the kinetic energy of the ball just before it hits the ground. Ladies and gentlemen, students are always thinking here that kinetic energy is equal to 1 over 2 mv square. So mass is given but velocity is not there, so you cannot find the kinetic energy from this type of data. What should we do then? We have to think that at the top, whatever the potential energy is at 2.5 meter height, when we release it, this potential energy is converting into kinetic energy. And before the impact, when they are touching the ground, everything is zero, kinetic energy as well as potential. But before the impact point, we have to find the kinetic energy. Then first we will find the potential energy at height. So here they are asking that find the kinetic energy. Now at height, uh, H at height 2.5 meter, the potential energy is mgh. So we are putting these values 0.12 into 10 into 2.5, and the unit of potential energy is joule. So we are calculating these things, that is 3 joule. So at height, which is at 2.5 meter from the ground, here we found the potential energy. Now the question is asking that find the kinetic energy before the impact point. So when this rubber ball is coming down, all that potential energy will be converted into kinetic energy. We studied that in the interconversion of energies video. So you can go there and in greater detail you can learn it there. So whatever the potential energy was here, all the energy, potential energy will be converted to kinetic energy. Uh, at the impact point, at the impact point, all the gravitational potential energy will be converted into kinetic energy. So whatever potential energy the ball was having at the top will be the kinetic energy before the impact point. So kinetic energy is equal to 3 joules. And that's it. That is the answer of the first part. Now, the second part is saying that calculate the velocity of the ball just before it hits the ground. So, here in the second part, we will find the velocity, which is V. As kinetic energy is equal to 1 over 2 mv square. So we found kinetic energy is 3 joules. So we wrote instead of this kinetic energy is 3, and m is given as 0.12, and we are finding the velocity. So we will leave it as it is. Now I am rearranging this. So 2 multiplied by 3 divide by 0.12, and here we will take square root on both sides of the equations. So this square will cut with this under root sign, and when we are taking the under root of 50, the under root of 50, so it will be v will be equal to 7.07 meter per second. Or we can write v is equal to 0.1 meter per second, and that is the ultimate answer. Now quickly we are turning our focus to question number 8, and question number 8 has given us this scenario. There is a skier jumping point A and B. The skier is starting from here and all the way coming down, and when he is ready to jump, that point is considered to be the B1. A point is 80 meter above the ground level, and the jumping point B is 20 meter above the ground floor. So the question is saying, but before that I can see that there is a small part. Give one in the 7th question. Give one reason why the ball rebounds to a height of less than 2.5 meter above the ground. When the ball is coming from here and it is hitting the ground and bouncing back, it is not going again to 2.5 meter high. Why it is So, because the upward motion in the ball has to do, because I am writing it here, because the rubber ball after hitting the ground, some of its kinetic energy is converted to sound energy, and to internal energy, which is also known as heat energy. So whatever energy the ball was having at a height of 2.5 meter was the potential energy. When the ball was coming down, that potential energy was converting to kinetic energy. So when it hits the ground, some of its energy is wasted in the sound energy which is dissipating in the surrounding air, and heat energy as well. So it means that some of its energy is lost. So the ball is not having that energy which was at height 2.5. So this time the ball will rebound back less than 2.5 meters. So the ball will rebounds back to a height less than 2.5 meter. Okay, now we discuss this scenario. This is given in the book. Let us understand the question. A skier stand at A at the top of the skiing ski jump shown in the diagram. He moves from A to B and takes off for his jump at B. Starting from point A, gaining kinetic energy, converting that potential energy at A into kinetic energy. When he reaches at point B, he is ready to take off for his jump. Now, A part is saying that do what? A part is saying if his mass is 80 kilogram, 8 8 point A, M is equal to 80 kilogram. This is given in the question. Calculate the change in gravitational potential energy. Gravitational potential energy. Here the height is given to us as 80 meter as well, and you know the value of G is 10 meter per second square. So the question is asking calculate the change in gravitational potential energy between A and B. First, we are finding potential energy at point A. So, potential energy at point A will be equal to mgh1. We are considering this is h1 and we are considering this is h2, which is 20 meter. It is given in the book. So we are writing m, whose values is 80, G is 10, and then again it is 80 joule. So when we calculate it, it will be 64,000 joule. Now at point point B, we will have to calculate the potential energy. So, potential energy at point B is equal to mgh2. Here in this case, m is constant, that is 80, and g is 10, which is also constant, but h2 in this case is 20, and the unit will be joule. When we are calculating this, it is equal to 16,000 joule. Now we found both the energies at point A and B. Now we are finding the difference, which is what the question is asking. Difference between potential energies at A and B, at points A and B. So that will be equal to 64,000 minus 16,000 joule. So when we uh, subtract it, it will be 48,000. That will be 48,000 joule, which can be written as 14 into 10 raised. Let me explain it a bit further. Joule. So I can write 48 into 10 raised to the power 3 joule, and then we can write 48 kilojoule. So that is the ultimate answer of this question. Okay, remember this. That was the A part. Now we are turning to the B part. If 75% of this energy becomes kinetic energy of the sphere at B, calculate in the B, we have to calculate what? We have to calculate the kinetic energy of the sphere at point B. So at point B, we calculated the energy as 48,000 joule. So we have to find 75% of energy at point B is equal to 75% multiplied by 48,000, which is this value 48,000. So these two zeros will be cancelled with these two zeros, and when we multiplied it, so it will be 36,000 joule, which can be written as well 36 kilojoule. Kilo means 1000. Okay. Now the next question is saying the speed at which it arrives at B. Here we have to find in the second part V, the speed at which the skier arrives at point B. What will be the speed? If he or she is starting from 80 meter above the ground. So we found potential energy at A and we found the potential kinetic energy at B. So we say that kinetic energy at point B will be equal to potential energy at point A. So we found that 1 over 2 1 over 2 mv square is equal to 36,000. We found that 36,000 because the height is here, so it will play a very important role inside this 20 meter. That B, this will be 20 meter and here it is 80 meter. So don't consider that the whole of the potential energy will be converted. At B it is 36,000 joule. So we are writing 1 over 2 into m, and m is given as 80 and v square we have to find, and here it will be 36,000 joules. Ladies and gentlemen, we have to leave this on this side. So we will write V square is equal to 36,000 multiplied by 2 divided by 80. And in the next step, we have to take the under root on both sides. So this under root will be cancelled with this one, and when we calculate this, it will be equal to 900 under the root, and sorry, it is v because it is cancelled. So 30 meter per second is the value of this. With this, we came to the end of this exercise. Hopefully, you have learned it. Now, we are starting unit number 7. In fact, topic number 7. There are 25 topics we have to cover in this course, and today we are going to introduce only the topic pressure. The subsequent topics will be explained in the other upcoming videos. Ladies and gentlemen, pressure is a term we are frequently listening in our daily lives. For example, we are saying that the gas pressure is less. There is a pressure cooker in which we are cooking the things. Atmospheric pressure is another term we are hearing in science very frequently. What is pressure? Today, let me introduce with the concept of pressure. Ladies and gentlemen, there was a mayor in 1654 in a German town. He put together two huge hemispherical cups together, and by certain means he was able to remove the air inside that hemispherical attachment inside that, which was like a ball in the two parts. He was being able to remove the air inside. When he removed the air, it was almost impossible to separate those two hemispheres from each other by hanging a huge amount of weights inside the downward hemisphere. Let me give you another example. If there are two very small hemisphere and we connect it and remove the air through air removing pump from the inner side of that ball, hollow ball, then it is said that if 15 horses are fastened on one side of a very small hemisphere and 15 horses on another side, they were not being able to separate those two small hemispheres. Do you know what makes these hemispheres put together so firmly? It is called pressure of external air. So in this unit, we will give a look to the pressure. We will also learn that what is atmospheric pressure and what are the effects of pressure on the different scenarios. Let me first uh, define the pressure, but before that, let me give you an example. If a lady is wearing a stiletto shoes, high heel shoes, and that stiletto heels well, sink down in the soft ground more, then the lady is wearing a flat shoes, a sole with the flat shoes. The stiletto will sink down further while the flat shoes will not sink down that much further. Let me introduce, because that is putting more pressure. The stiletto heels shoes is putting more pressure on the earth than the flat shoes. So pressure is defined as the force per unit area. Mathematically, P is F divided by A, where P is the pressure, F is the force, and A. Ladies and gentlemen, the unit of pressure is Newton meter square. The SI unit is Pascal. which is PA. Now I given you an example that stiletto heel will exert more pressure on the ground because its area is small. It means that pressure is inversely proportional to area in contact. So if area is small, pressure will be more because it is inversely, and this is the meaning of inversely proportional. So here the area is in case of the flat shoes, which is like this, so more area is in contact as compared to this one. So more area, less pressure. Less area in contact, more pressure will be there. So you have to understand that pressure is equal to force per unit area. This stiletto shoes and flat sole shoes are exerting the same pressure because the weight of the lady is the same in both cases, but area is different. So this will sink down more and this will sink down less. Okay, ladies and gentlemen, that was an introduction to the pressure. In next video, we will give a look to the atmospheric pressure and other terminologies. Thank you very much for watching. Allah Hafiz.